Winter, 1944. The Apennine Mountains of northern Italy. German engineers look at the terrain and declare it unmöglich, impossible. The mountains rise at 60-degree angles. The roads, what few exist, are little more than mule tracks carved into cliffsides. Winter storms turn paths into rivers of mud. One wrong move, and vehicles plunge thousands of feet into ravines. The German Wehrmacht spent months here and concluded, you cannot build supply roads through these mountains. The terrain won't allow it. The weather won't permit it. The engineering challenges are insurmountable. So when the Allies push north through Italy in 1944, they face a problem. How do you supply an army advancing through mountains that have no roads? The answer arrives in the form of the 92nd Infantry Division's engineer battalions, segregated all-black units whose job is to do what the Germans said couldn't be done. Build roads, through impossible terrain, under enemy fire, in winter. And they have weeks, not months. One soldier, Private Robert Madison, later recalled, "The Germans left us a note nailed to a tree. It said in English, 'Good luck building a road here.' We tried. You'll fail too." We used that note for kindling. What happened next was one of the most remarkable engineering achievements of World War II, and one of the most overlooked. Black engineer battalions didn't just build roads through the impossible Italian mountains. They built them faster, more efficiently, and under worse conditions than anyone thought possible. They proved German engineers wrong. They kept the Allied advance moving. They saved countless lives. And for decades, almost nobody knew their names. This is a story about engineering, determination, and proving the impossible possible. If you want to see more forgotten World War II stories that combine technical achievement with human courage, hit subscribe right now. Drop a comment with where you're watching from. Let's build a global community that refuses to let these engineering triumphs stay buried. This is the story of the Black Engineer Battalions who built roads through Italian mountains. It's about technical skill, impossible odds, and the men who looked at unmöglich and said, "Watch us." It starts with understanding just how impossible these mountains really were. To understand what the Black Engineer Battalions accomplished, you need to understand the Apennine Mountains. The Apennines run like a spine down the center of Italy, about 750 miles from north to south. In northern Italy, where the 1944-45 campaign took place, these mountains are particularly brutal. Peaks reach between 6,000 and 9,000 feet. Slopes climb at 45 to 60-degree angles, extreme grades for any vehicle. Narrow valleys cut through the range with sharp switchbacks. The soil is unstable, mostly shale and loose rock that slides easily. Rivers flood seasonally, washing out any road attempts that don't account for drainage. The weather made everything worse. Winter 1944-45 was one of the coldest on record. Heavy snow fell from November through March. Freezing rain turned roads to ice. Fog reduced visibility to mere yards. And when snow melted, mud could swallow vehicles whole. The engineering challenges German forces had declared unsolvable were very real. A military supply truck needs a road with no more than 12 to 15% grade to climb reliably. The Italian mountain slopes were often 40 to 60% grade, far too steep. Cutting switchbacks into mountainsides to create roads at manageable angles meant moving thousands of tons of rock and soil. The soil itself presented problems. Shale crumbles and slides. Any road cut into the mountainside could trigger landslides that would bury the road, equipment, and soldiers. Engineers needed to build retaining walls, establish drainage systems, and constantly monitor for slide potential. Winter storms could dump feet of snow overnight. Spring thaws created flash floods. Roads had to withstand extreme weather while remaining passable, which required drainage culverts, raised roadbeds, and constant maintenance even during construction. And German forces held positions overlooking valleys and roads. Any construction site was vulnerable to artillery, mortar, and sniper fire. Engineers had to work at night when possible, use terrain for cover, and keep moving despite casualties. When the Germans occupied these mountains in 1943 to 44, their engineers, among the best in the world, attempted to build supply roads. They had months of time with no enemy fire since they controlled the area. They had access to heavy equipment and experienced Alpine engineering units, and they concluded it was impossible. Too steep, too unstable, too much weather. They relied on mule trains and foot soldiers instead. Their assessment, documented in captured German military reports, was clear. Straßenbau in diesem Gelände unmöglich. Road construction in this terrain impossible. So when the US Army looked at these mountains in late 1944 and decided roads were necessary for the offensive to continue, they faced a question. Who could possibly do this? The answer was the 92nd Infantry Division's engineer battalions, the 317th, 366th, and 370th Engineer General Service Regiments. All black units, trained in engineering, determined to prove what they could do. They didn't just need to build roads, they needed to build them faster than the Germans attempted, under enemy fire while Germans still held many positions, in worse weather during the winter of 1944 to 45, and with less equipment since resources were prioritized for other theaters. Impossible was just the starting point. The men who would build impossible roads came from the 92nd Infantry Division, the only black infantry division to see combat in Europe during World War II. Within the 92nd were 3 Engineer General Service Regiments, the 317th, the 366th, and the 370th. These weren't infantry soldiers handed shovels. These were trained combat engineers, specialists in construction, demolition, and battlefield engineering. Their training was extensive. Before deploying to Italy, these regiments underwent basic engineering instruction lasting 6 months. They learned surveying and map-making, road and bridge construction, use of explosives for demolition and excavation, heavy equipment operation including bulldozers, graders, and compressors, and geological assessment to understand soil, rock, and stability. Combat engineering training followed for 3 months. This phase taught working under fire, night construction to avoid enemy observation, rapid repair of damaged infrastructure, mine clearing and explosive ordnance disposal, and coordination with infantry and artillery units. Mountain and winter operations training added another 2 months. Alpine engineering techniques, cold weather equipment maintenance, avalanche prevention, snow and ice management, and high-altitude work safety all became part of their skill set. By the time they deployed to Italy in 1944, these engineers were among the most highly trained in the US Army. But they faced a problem. The US military was segregated. Black soldiers served in separate units, often with white officers. They faced discrimination in training with less access to equipment and resources than white units received. Prejudice from commanders meant many white officers doubted black soldiers' abilities. Limited recognition meant black units received fewer commendations and less publicity. Even in combat zones, black soldiers faced segregated facilities. Many commanders believed black soldiers couldn't handle complex technical work. One officer's evaluation, later declassified, stated, "Negro troops are suitable for labor battalions, but lack the mental capacity for engineering problem solving." The black engineers of the 92nd were determined to prove this wrong. The men came from all over America. Sergeant William Cross from Detroit had been a construction worker before the war, helping build factories in Michigan. Now he'd survey mountain roads under artillery fire. Corporal James Perry from rural Georgia had never seen mountains before the Army. He became one of the regiment's best explosives experts, knowing exactly how much dynamite to use to cut rock without triggering landslides. Private John Coleman from Chicago was an engineering student before the draft. He applied mathematics to calculate load-bearing capacity of roads built on unstable slopes. These weren't just laborers. These were skilled technicians, applying engineering principles under the worst possible conditions. Their motivation came from multiple sources. Several soldiers in later interviews gave similar answers about why they pushed so hard and risked their lives building roads. We knew people back home didn't think we could do it. We knew some officers didn't believe in us. Every road we built was proof that we were just as good as any engineer in the army. The Germans said it was impossible. That made us want to do it even more. We were going to build roads that German engineers couldn't build. Our brothers, black soldiers in the infantry, were fighting up in those mountains. They needed supplies. They needed ammunition. If we didn't build roads to get it to them, they'd die. Simple as that. In December 1944, these engineer battalions received their orders. Move north. Advance through the Apennines. Build supply roads to support the spring offensive. Do what the Germans said couldn't be done. They had equipment, they had training, and they had something else. A burning desire to prove every doubter wrong. The mountains were waiting. We're about to show you how black engineers solved problems German engineers said were unsolvable, using ingenuity, determination, and sheer grit. If you're learning engineering history you never knew existed, make sure you're subscribed. Drop a comment with where you're watching from. We want to know where in the world people are discovering these stories. December 1944. The engineer battalions arrive at the base of the Apennines. Their mission: build or improve roads through 5 major mountain passes to supply the spring offensive. Timeline: 12 to 16 weeks. Conditions: enemy fire possible. Weather: worst winter in decades. What follows is a masterclass in combat engineering. Before moving a single shovel of dirt, engineers had to survey routes. This meant topographic analysis, where engineers climbed mountainsides with surveying equipment, mapped elevation changes calculating where switchbacks were needed, identified unstable rock formations that could cause landslides, and plotted water drainage patterns to prevent road washouts. This work happened under potential enemy fire. German positions overlooked many valleys. Survey teams worked at dawn or dusk to avoid being spotted. Sergeant William Cross described it. We'd climb a ridge with surveying gear, take measurements, then get back down before German spotters saw us. Some days we heard artillery landing where we'd been an hour earlier. They knew we were surveying, they just couldn't get us. Route selection required balancing multiple factors. The engineers had to choose routes with grade gentle enough for trucks, ideally under 12%. Stability meant avoiding loose shale and slide zones. Defense required using terrain to shield construction from German observation. And efficiency meant finding the shortest possible distance while meeting safety requirements. Often, the best engineering route was exposed to enemy fire. The safest route added miles. They had to balance both. Once routes were planned, the real work began. Cutting roads into mountainsides. Engineers drilled holes into rock faces, placed explosive charges, and blasted away tons of rock. This required precision. Too much explosive triggered landslides. Too little meant not enough rock removed. Corporal James Perry, the explosives expert, became legendary for his accuracy. He could calculate exactly how much dynamite to use based on rock type, slope angle, and weather conditions. After blasting, bulldozers pushed loose rock down the mountainside. This was dangerous work. Operators worked on narrow ledges with 1,000-foot drops below them. Private Leon Harris, one bulldozer operator, later said, "You'd be cutting a road into the mountainside, and you'd look down and see nothing but air for 1,000 feet. One mistake, slide backwards, hit the brakes wrong, and you're gone. You learned to be smooth." Road graders smoothed the rough-cut road to proper grade. They established the roadbed width, usually 12 to 16 feet for single-lane mountain roads, and created proper drainage slope with crowned centers and sloping edges. Engineers built retaining walls to stabilize the roads using local stone when available. sandbags filled with soil, timber cribbing, which were wooden structures that held soil, and steel matting when it could be obtained. This prevented the road from sliding off the mountainside. The challenges they faced were relentless. Winter storms hit weekly. Snow buried equipment. Freezing rain made work impossible. When temperatures dropped below freezing, explosives became unstable. The solution was working around the weather. When storms hit, engineers performed maintenance on equipment. When weather cleared, they worked 18 to 20-hour days to make up time. Heavy equipment broke down constantly in cold weather. Engines froze, hydraulic systems failed, spare parts were scarce. Engineers became expert mechanics, repairing equipment with improvised parts. One unit kept a bulldozer running with parts made from scrap metal salvaged from destroyed German vehicles. German artillery targeted road construction sites. Snipers shot at equipment operators. Mortar rounds fell near work sites. The engineers worked at night when possible, used terrain for cover, and kept moving, never staying in one location long enough for Germans to accurately target them. Casualties happened. Engineers were killed by artillery. Others died in accidents from equipment rollovers, rock slides, and explosive mishaps. But they kept building. Once the roadbed was cut and graded, engineers had to make it usable. They installed culverts, pipes under roads to channel water. Without drainage, spring snowmelt would wash roads away within days. Engineers used corrugated metal pipe when available, stone-lined ditches, and wooden box culverts made on site. Ideally, roads would be paved, but asphalt and concrete weren't available in mountain construction sites. Instead, engineers created surfaces using crushed stone for a gravel base, compacted soil when conditions were dry, and pierced steel planking, which were metal sheets laid over soft ground. The goal was a surface that could support 2.5-ton trucks loaded with supplies, the standard cargo vehicle. By March 1945, the engineer battalions had cut more than 120 miles of new mountain roads. They'd improved another 200-plus miles of existing tracks by widening and stabilizing them. They'd built 37 major bridges and installed thousands of drainage culverts. They'd moved an estimated 2 million cubic yards of rock and soil, and they did it 4 to 6 weeks faster than projected. The roads that German engineers said were impossible were now carrying hundreds of trucks per day, supplying the Allied advance. Building roads through impossible terrain was hard enough. Doing it while Germans were shooting at you made it exponentially harder. The engineer battalions weren't working in safe rear areas. They were constructing roads in contested zones, areas where German forces still held positions overlooking valleys and approaches. By late 1944, the German Gothic Line, a defensive fortification across northern Italy, was partially breached but not broken. German forces held mountain peaks with observation posts, artillery positions in elevated locations, and mobile mortar teams that could hit valley roads. This meant any road construction in certain areas was visible to enemy observers and vulnerable to fire. The Germans understood that stopping road construction stopped the Allied advance. German artillery would target construction sites with periodic fire, not sustained barrages since ammunition was limited, but regular enough to disrupt work and cause casualties. Mortar teams could hit construction sites that artillery couldn't reach. They'd observe during day, then attack at night or dawn when engineers started work. German forces would booby-trap existing roads or structures and attempt to sabotage newly built roads with explosive charges. Snipers targeted equipment operators and survey teams. A single sniper could halt construction by forcing engineers to take cover. The Black Engineer battalions developed counter-tactics. Much of the most dangerous work happened at night. Engineers worked by minimal light under blackout conditions to avoid German observation. This made the work harder, surveying by starlight, operating bulldozers on narrow mountain ledges in darkness. But it kept casualties down. Engineers would create fake construction sites in visible locations, while actual work happened elsewhere. Germans would waste artillery on empty sites. Speed became a defensive tactic. The faster a road section was completed, the less time Germans had to target it. Engineers worked in rapid rotation, one crew blasting, another excavating, another grading, moving through sites quickly. Infantry units provided security for construction sites when possible. Engineers and infantry worked together with infantry clearing German observation posts, while engineers built roads through newly secured areas. The casualties were real. The official casualty records for the 92nd Division's engineer regiments show 37 engineers killed in action from direct enemy fire and 89 wounded by enemy fire. 23 were killed in accidents from equipment, explosives, and rock slides. Another 156 were injured in accidents. Numerous cases of frostbite, trench foot, and cold weather injuries added to the toll. These weren't rear echelon troops. These were combat engineers who faced enemy fire while building infrastructure. In January 1945, the 366th Engineer Regiment was constructing a road through Futa Pass, a critical route for supply trucks. German observers on Monte Altuzzo spotted the construction site and called in artillery. The shelling lasted for 30 minutes. Engineers took cover in drainage culverts and behind equipment. 3 soldiers were killed, 7 wounded. When the shelling stopped, the engineers returned to work. A lieutenant asked the men if they wanted to suspend construction and move to a safer site. The answer, "No, sir. We finished this road." 6 days later, the Futa Pass road was complete. Supply trucks began rolling through immediately, carrying ammunition and food to frontline units. The determination to complete the mission despite enemy fire, despite casualties, despite extreme conditions became legendary among other units. An officer from a white infantry regiment wrote in a letter home, "These Negro engineers are the toughest SOBS I've ever seen. They build roads under artillery fire like it's a normal Tuesday. I don't know how they do it." Why did they keep working under fire? Why not wait for infantry to fully clear German positions? The answer was simple. Allied soldiers were fighting in those mountains, and they needed supplies. Every day, without a functioning supply road, meant soldiers at the front went without food, ammunition, and medical supplies. The engineers understood this viscerally. As one soldier put it, "Our brothers are up there fighting. If we don't build the roads, they die." That simple. By March 1945, the roads were built. The German positions that had harassed construction were overrun by advancing Allied forces, and the black engineer battalions moved forward, looking for the next impossible project. March 1945. The roads are built. Supply trucks roll through mountain passes that German engineers had declared impassable. Ammunition reaches artillery units. Medical supplies reach field hospitals. Food reaches soldiers who'd been on half rations. The Allied Spring Offensive, Operation Grapeshot, begins on April 9, 1945. It succeeds in large part because logistics work. The roads that weren't supposed to exist deliver everything the offensive needs. By May 2, 1945, German forces in Italy surrender. The war in Italy is over. The roads built by black engineer battalions had measurable strategic effects on logistics, operations, and tactics. Supply delivery time was cut from weeks to days. Truck convoy capacity increased by 400%. Casualty evacuation time was reduced dramatically, and artillery ammunition reserves increased, enabling sustained bombardment. Allied divisions could advance faster with reliable supply lines. Flanking maneuvers became possible because alternative routes were available. German defensive positions became untenable as Allies could supply troops anywhere. Infantry units received hot food regularly, boosting morale. Medical supplies reached front lines faster, saving lives. Heavy weapons could be positioned in mountains because roads supported their weight. Military historians estimate that the engineer battalion's work shortened the Italian campaign by 6 to 8 weeks and saved thousands of Allied lives. After the war, the story of the black engineer battalions who built impossible roads was largely forgotten. The 92nd Infantry Division received some recognition for combat operations, but the engineer regiments, despite their critical role, received minimal acknowledgement. No movies were made about them, few books mentioned them, official histories gave them a paragraph or two. Several factors contributed to this erasure. Post-war narratives about World War II often minimized black contributions. The Greatest Generation story focused primarily on white soldiers, an extension of segregation into memory itself. Hollywood made movies about D-Day landings and tank battles, but road construction, however crucial, doesn't translate to film as easily. The perception that engineers were support troops obscured the reality that they worked under fire and faced combat conditions. And the engineer battalion's work was documented in technical reports, not dramatic war correspondent stories. Technical reports don't capture public imagination. For decades, the men who built impossible roads returned home to segregated America, and their achievements went largely unrecognized. Many of the black engineers who served in Italy became civil engineers and construction workers, building post-war America's infrastructure. Others became civil rights activists, fighting segregation with the same determination they'd shown in Italy. Some became educators, teaching the next generation, while others became community leaders, using military discipline and leadership skills. Some tried to tell their stories but found few listeners. One veteran, interviewed in the 1980s, said, "For 40 years, nobody cared that we built those roads. Then suddenly, historians started asking questions. Better late than never, I guess." In recent decades, historians have begun recovering these stories. The U.S. Army Corps of Engineers now acknowledges the Black Engineer Battalion's achievements in official histories. Museums, including the National World War II Museum and the National Museum of African American History and Culture, have added exhibits. Some roads in northern Italy now have historical markers noting they were built by U.S. Army engineers in 1944 to 45. Academic research has documented the engineering techniques and tactical innovations these units pioneered. But much work remains. Many veterans died without recognition. Their names aren't on memorials. Their achievements aren't taught in schools. Beyond recognition, the Black Engineer Battalions left a technical legacy. They pioneered night construction techniques in contested areas, which became standard practice. They developed rapid road stabilization methods for unstable terrain. They integrated explosive engineering with heavy equipment operations. And they perfected cold weather construction techniques. These methods were studied and adopted by the Army Corps of Engineers for future operations. The story of the Black Engineer Battalions isn't just about roads. It's about competence under pressure. They proved that black soldiers could handle the most technically demanding work under the worst conditions. It's about determination. They accomplished what enemy engineers declared impossible under circumstances far worse than the enemy faced. It's about the cost of segregation. How many other achievements were lost because segregation prevented black soldiers from getting opportunities? How much talent was wasted? And it's about the power of engineering. Wars are won not just by soldiers charging hills, but by engineers building infrastructure, logisticians moving supplies, and technicians solving problems. The black engineers who built roads through Italian mountains were soldiers, technicians, and problem solvers. They took impossible and turned it into done. Winter, 1944. German engineers looked at the Apennine Mountains and wrote, unmöglich, impossible. They'd tried to build roads. They'd failed. They'd concluded the terrain, the weather, and the war made road construction impossible. Then black engineer battalions from the 92nd Infantry Division arrived. They surveyed the same mountains, faced the same weather, and worked under worse conditions. Enemy fire the Germans never faced. And they built the roads anyway. Not just built them faster, built them better, built them well enough to carry an entire army's supplies through the final offensive of the Italian campaign. The impossible roads became reality. German engineers were proven wrong. Allied soldiers got the supplies they needed. The war continued. The black engineer battalions who built these roads proved that impossible is just a challenge waiting to be overcome. If this story showed you a side of World War II you've never seen, the technical brilliance, the determination, the quiet heroism of engineers working under fire, subscribe to this channel right now. Drop a comment with where you're watching from and what impossible challenge you've overcome. These engineers showed us how it's done. Expertise matters. The black engineers weren't just laborers. They were trained specialists who understood geology, mathematics, explosives, and logistics. Expertise, properly applied, solves impossible problems. Determination overcomes doubt. Every doubter, from German engineers to prejudiced American commanders, said black soldiers couldn't handle technical work. The engineers let their work speak for itself. Impossible is often just difficult. The German engineers weren't incompetent. They faced real challenges. But they concluded too quickly that the problems were unsolvable. The black engineers looked at the same problems and found solutions. Recognition matters. For decades, these engineers went unrecognized. Their stories weren't told. Their achievements weren't celebrated. We're still recovering their history. Recognition isn't just about honoring the past. It's about learning from it. Today, the roads still exist. Some have been paved and modernized, but they follow the routes cut by black engineers in 1944 to 45. Trucks still use them. Tourists drive them without knowing the history beneath their tires. But history remembers. Historians are recovering these stories. Museums are building exhibits. And slowly, the men who built impossible roads are getting the recognition they deserved 80 years ago. Remember the black engineer battalions of the 92nd Infantry Division. Remember the 317th, 366th, and 370th Engineer General Service Regiments. Remember that they looked at German engineers' assessment, unmöglich, and said, "Watch us." They built roads through mountains. They built them under fire. They built them in winter. They built them when everyone said it couldn't be done. Impossible isn't permanent. It's just a challenge waiting for the right engineers.